Welcome. Today we are going to look at solving absolute value inequalities. First, let's talk about what an inequality is. And this is a review of some things that you did in Algebra 1. So if I had -2 is less than x is less than 5, we would call that an and. And the way that we would graph it would be with a -2 and a 5. Remember that if it's negative, we graph it with an open circle, or excuse me, negative. If it's less than, we graph it with an open circle. If it's less than or equal to, we graph it with a solid dot. So what I'm going to do is I'm going to make an open circle here and one here, and then show that the x is in between -2 and 5, or it is greater than -2 and it's less than 5. Okay? All the values in between have to be true for both of the situations, -2 and 5. Okay, let's do another one. Let's do where x is less than -2 or x is greater than 5. So this time we are doing an or, and the x values can be less than -2, or it's okay if they are greater than 5. So they don't have to be true for both. They only have to be true for one or the other. All right, now that we have reviewed that, let's talk about what it would be like to solve an absolute value inequality and then graph it. Okay, let's use this example. Our phone can work best at a degree of about 72. Okay, that will be our total. However, there is a tolerance of plus or minus 20 degrees. Okay, now I'm really making up numbers here because our phone could probably work in the Texas heat much better than that. So let's just use these numbers for the sake of our example. Okay, I'm going to create an absolute value inequality with these numbers. Okay, I want to stay within less than the 20-degree tolerance. So I'm going to stay either greater than 72 or less than 72 within 20 degrees. So I can be 92 or I can be 52. To write this, I'm going to use x minus and my total number. My tolerance number, or my variance, is going to be the 20, the one that I want to be the less than 20. In this case, this will be my total. You'll do this for every single one of these problems that is like this. You'll always do a less than right there, and your tolerance will be here. Okay? All right. So if I were to solve this, I would figure out that x would equal 92. Okay. Or x would equal 52, because then that would give me a -20, and -20 absolute value 20 would still equal 20. The reason why I use the less than symbol is to show that the degree between 72 and 92 is within the allowable temperature, or the degree between 72 and 52 is within the allowable temperature. Okay? So this is the reason why we use absolute value inequalities, to show that a total and a tolerance between that total where we can go up and down. All right, let's try an equation or an inequality where we have to actually solve it. Okay, so let's first solve the one that we're using. We're going to do x minus 72 is less than or equal to 20. Okay, we're going to use the same trick that we used before. We're going to say x minus 72 less than or equal to 20. And we're going to say x minus 72. And remember, we got to use the negative 20. Okay, because we want to find out which one's going to be positive, which one's going to be negative, just like we did when we solved the absolute value equations. The only difference with this is that when you have a less than, greater than symbol to deal with, if the one on the left is less than, because that's your original, the one for the negative is going to be flipped. Okay, so now we're going to solve. If we add 72 to both sides, of course we'll get x less than or equal to 92, which is what we thought. It had to be less than 92. Also, if we add 72 on this side, we're going to get our x greater than 52, which is what we were thinking before as well. It has to be between 52 and 92 since 72 is our optimum. Okay, so let's do this real quick. I'm going to do this right here where I graph this, because you'll be asked to graph. Okay, our answers are 52 and 92. Okay, and if I make a dot here and draw my line, and remember it has to be a dot because it's equal to, that'll be my graph. Okay, now let's do another problem that is just a little bit more difficult to solve. Okay, so this time we're going to do a problem that looks like this. 2 times 4x plus 1 minus 5 is less than or equal to 1. So we have to get rid of this number and this number first before we can move things or split it up into its positive and negative equations. Okay, so what I'm going to do is I'm going to take the 5 and add it to the other side. Okay, so if I add it to the other side, I get 6, and then I'm going to divide the 2. And that'll give me the absolute value of 4x plus 1. Everything except for the absolute value moves over to the other side. Okay, all right, so let's do this. Let's split up into our positive and negative sides. Okay, so let's set it up with 4x plus 1 is less than or equal to 3. And then we'll do 4x plus 1. Now, this is the negative. So when you have the negative, you flip the inequality. Okay, so let's solve each one. If I subtract 1 on this top one here, I'm going to get a 2. And if I divide by 4, I'll get 1/2. Okay, if I subtract 1 on this one, I'm going to get -4. And if I divide by 4, I'm going to get -1. All right, so let's graph. Do the graph right here. So I've got -1 and 1/2. Okay, I'm going to use my solid dot and then draw my line in between. Okay, so now what we have to do is try a problem where it starts out greater than. Our problem is going to be the absolute value, 3x minus 2 plus 5 is greater than 9. Okay, so remember that we need to move this extra step. So this extra step is going to move first, this 5. So that'll give me the absolute value of 3x minus 2. If I subtract 5 on the other side, I get 4. So that's what I'm going to work with. I'm going to set up my two equations. I've got 3x minus 2 is greater than 4. And then I've got 3x minus 2. Flip the inequality and make it a negative 4. Okay, for my positive and negative side is done. Okay, so I'm going to solve each equation. If I add 2 on the top equation, or inequality, I get 6. And then if I divide by 3, I get 2. Okay, for the bottom inequality, if I add 2, I get negative 2. If I add 2. And if I divide by 3, I get negative 2/3. In Algebra 2, we usually leave it as a fraction unless we're doing some word problems that require different measurements in science, or like money. Then we'll round to about 3 decimals. If it's money, it's 2 decimals. Okay. All right, so I've got these two right here, and I'm going to graph it. This is my negative 2/3, and this is my 2. This is going to be an open circle because it's not an equal to. Okay, it's greater than 2. Remember, this is an or it's less than 2/3. Okay. All right, so that is it for this video. We're going to practice solving absolute value inequalities, and we're also going to practice creating the equation like we did at the very beginning of the video. Okay? If you have any questions, please let me know. Have a great day.